The process begins with auto cutting, where sheets of metal are precisely cut into the initial shape of the knives using automated machinery. The cut metal pieces undergo sand injection, where fine sand is blasted onto the surface to clean. The cleaned knife blanks are then placed in an oven for heating. After annealing, the knife blanks are transferred to a CNC hammer. The shaped blanks are then passed through a rolling press. This step further refines the thickness and ensures uniformity across the entire length of the blade. In this stage, the knife blanks are trimmed to their final profile using precision cutting tools. The profiled blanks undergo side grinding to smooth and even out the edges. This ensures that both sides of the blade are symmetrical and free of rough edges. Further grinding is performed to refine the blade's surface and prepare it for the next stages. This step involves multiple passes to achieve the desired smoothness and sharpness. The knife blanks are then pressed to ensure they are perfectly flat and straight. This specialized heat treatment process hardens the blade, enhancing its strength and durability. The exact parameters of this step depend on the type of steel used. The hardened blades undergo blade grinding, where the primary bevel is formed. Further grinding is done to refine the blade's edge and achieve the desired sharpness. This step involves fine-tuning the blade's geometry. For knives that require serrated edges, teeth cutting is performed at this stage. Automated polishing machines are used for final polishing, ensuring a consistent and high-quality finish on each blade. The polished blades are thoroughly washed to remove any residues from the polishing process. This ensures that the blades are clean and ready for the final inspection. Final inspection. The last step is a final inspection where each blade is checked for defects, sharpness, and overall quality. Only blades that pass this rigorous inspection are deemed ready for market. The birth of a WÜSTHOF knife is a meticulously orchestrated process that blends traditional craftsmanship with modern technology. Each WÜSTHOF knife begins as a single piece of high-carbon stainless steel, chosen for its durability and ability to hold a sharp edge. This steel is first heated to an incredibly high temperature in a forging process that ensures the metal is malleable and ready to be shaped. Once heated, the steel is precision forged using a drop hammer, a method that compresses the metal into a die to form the basic shape of the knife. This step, critical to the knife's structural integrity, distinguishes WÜSTHOF knives as exceptionally strong and durable. After forging, the knife undergoes a series of grinding and honing processes. This is where the blade is shaped to its precise geometry and thickness, followed by sharpening to create a fine edge. Advanced grinding machines and skilled artisans work in tandem to ensure each blade meets the highest standards of sharpness and balance. The handle, typically made from high-quality synthetic materials, is then attached. This involves securing the handle to the blade tang with rivets, ensuring a secure and comfortable grip. Each handle is ergonomically designed to provide a perfect balance and ease of use. The final polishing process of a knife involves smoothing and refining the blade to achieve a flawless finish. Artisans use specialized tools to polish the blade and handle, ensuring both aesthetic appeal and optimal functionality. This step guarantees the knife's signature gleam and superior performance. The American Bladesmith Society proudly presented the 2016 International Mastersmith Knife of the Year, crafted by the renowned mastersmith Rodrigo Essefredo from Nova Petrópolis, Brazil. This exquisite knife, dubbed the modern Gaucho, exemplifies Essefredo's exceptional skill and artistry, which can be fully appreciated in the accompanying video detailing its creation process. Forged from Damascus steel in a striking W pattern, the knife boasts an integral construction that speaks to Essefredo's masterful control over this complex forging technique. Damascus steel, known for its strength, durability, and unique wavy patterns, further enhances the knife's aesthetic and functional qualities. The blade features a gold inlay stamp, adding a touch of elegance and distinction to the piece and highlighting the attention to detail that Essefredo is celebrated for. Knife enthusiasts and collectors had the exclusive opportunity to acquire this masterpiece on Saturday, June 4, 2015, at 10 a.m. in room number 103 during the ABS Knife Auction at the 2016 Blade Show in Atlanta, Georgia. This annual event, renowned for showcasing the finest custom knives from around the world, provided the perfect venue for unveiling Essefredo's latest work. Attendees were given a rare chance to own a piece of functional art that embodies the pinnacle of modern bladesmithing. Sharpening starts with coarse grit stones or diamond plates to shape the edge, followed by progressively finer grits to refine it. Consistent angle and pressure are crucial for an even edge. Polishing involves using finer stones, strops with compounds, or buffing wheels to smooth the blade surface and remove microscopic burrs. This enhances sharpness and creates a mirror-like finish. Regular maintenance, including honing with a steel rod, keeps the knife performing optimally. The handle of the modern Gaucho knife is crafted in Essefredo's signature keyhole style, characterized by a hidden tang and a polished border that seamlessly integrates with the blade. This design not only provides a secure and comfortable grip, but also showcases the flawless craftsmanship involved in its creation. The handle is made from desert ironwood, a dense and durable hardwood known for its rich, dark color and intricate grain patterns, further enhancing the knife's overall beauty and uniqueness. The modern Gaucho knife by Rodrigo Essefredo is not just a tool, but a testament to the rich tradition and evolving craft of bladesmithing, representing a perfect blend of historical craftsmanship and contemporary innovation. The knife forging process in Japan is a venerable tradition, rooted in the ancient techniques used for crafting samurai swords. When Japan opened to the world in 1868, and the carrying of swords was banned, many blacksmiths transitioned to making kitchen knives, preserving their exceptional craftsmanship. In Osaka, master blacksmith Shigeaki Morinaga exemplifies this heritage. Beginning his training at 15, Morinaga has devoted his life to the art of forging blades. In his clay furnace, he transforms a mixture of iron and charcoal into molten steel at 900 degrees Celsius. After letting the steel rest for 24 hours, he reheats and hammers it to remove impurities and shape it into a blade. His process involves meticulous steps, including assessing steel quality, quenching in water, and forming the blade's edge and back. Morinaga's blades are sharpened by Toshiko Nagata in Sakai, where the tradition of single-edged knives for precise fish cutting is upheld. Nagata hand polishes the blades with natural tones after an initial grinding. Handles are crafted from rare, non-decaying wood, heated and fitted to the tang of the blade. In Wuppertal, Germany, Helko axes are crafted through a traditional process that highlights the skill and artistry of the blacksmiths involved. Each axe head is individually forged by hand using a drop hammer on open dies. This method involves the blacksmith holding and shaping the hot steel with tongs as a hammer continuously strikes it at high speed. This demanding process requires a high level of hand-eye coordination and expertise, developed through years of experience, as every split-second decision affects the final product's shape and integrity. After forging, the smith imprints the Helko work crown logo onto the axe's cheek, leaving minimal supplementary work to preserve the unique forging marks on each blade, ensuring no two pieces are identical. This practice not only enhances the aesthetic appeal, but also signifies the handcrafted quality of each axe. An essential aspect of Helko axes is their Rockwell hardness, a measure of the steel's tempering. The steel must be perfectly balanced. Too soft, and it will require constant sharpening. Too hard, and it risks chipping or cracking during use. Helko's master smiths, with their extensive experience, have perfected this balance to create axes with superior edge retention, ease of sharpening, and resistance to chipping. The handles of Helko axes are crafted from Grade A American hickory, chosen for its exceptional bending properties, flexibility, shock absorption, and resistance capabilities. The hickory logs are cut into planks and air-dried for 9 to 10 months to achieve the ideal moisture content. This drying process ensures the wood's durability and strength, while the natural variations in color and grain add to the handle's unique character.
This is where the raw materials required for manufacturing. In the pressing workshop, specialized machinery is utilized to shape raw materials into preliminary components for the eyebrow trimmers. This process involves applying pressure to mold or cut the materials according to precise specifications, laying the foundation for subsequent manufacturing stages. In the heat treatment workshop, the shaped components undergo controlled heating and cooling processes to alter their physical and mechanical properties. This enhances the hardness, strength, and durability of the materials, ensuring they can withstand the rigors of eyebrow trimming. By subjecting the components to specific temperatures and durations, the workshop aims to optimize their performance and longevity, ultimately contributing to the overall quality and reliability of the finished eyebrow trimmers. In the blade edging and polishing stage, meticulous attention is given to refining the edges of the eyebrow trimmer blades. Highly skilled technicians utilize precision tools and abrasive techniques to create razor-sharp edges while ensuring uniformity across all blades. This process not only enhances the trimmer's cutting efficiency, but also minimizes the risk of skin irritation during use. Additionally, polishing is performed to smoothen the blade surfaces, further improving their glide and precision. The goal is to achieve impeccable sharpness and smoothness, guaranteeing optimal performance and user satisfaction with each trim. During blade edge testing, each eyebrow trimmer blade undergoes rigorous examination to verify its sharpness, integrity, and safety. In chrome plating, a thin layer of chromium is electroplated onto the trimmer components for enhanced durability and aesthetic appeal. Sintering involves heating powdered metal to fuse particles together. Color matching involves meticulous calibration and adjustment of pigments or dyes to ensure consistency in the color of components across all eyebrow trimmers. This process is crucial for maintaining brand identity and customer satisfaction, as it ensures that the final product meets aesthetic standards and reflects the desired color specifications accurately. In the batching room, components from various stages of production are gathered and organized into specific batches according to their type, size, or manufacturing requirements. This process ensures efficient flow and management of materials throughout the assembly process. By carefully grouping components together, it facilitates streamlined assembly operations, minimizes errors, and enables easier tracking and quality control. In the injection workshop, sophisticated injection molding machines are employed to fabricate plastic components for the eyebrow trimmers. This involves injecting molten plastic material into precision molds under high pressure, where it cools and solidifies into the desired shape. Skilled technicians monitor the process to ensure accurate dimensions and quality. The injection molding machine is a complex apparatus used to fabricate plastic components for eyebrow trimmers. It consists of a hopper that feeds raw plastic material into a heated barrel, where it is melted and injected into a mold cavity under high pressure. This process enables the rapid and precise production of intricate plastic parts with consistent quality. The injection molding machine is a complex apparatus used to fabricate plastic components for eyebrow trimmers. It consists of a hopper that feeds raw plastic material into a heated barrel, where it is melted and injected into a mold cavity under high pressure. This process enables the rapid and precise production of intricate plastic parts with consistent quality. In the assembly workshop, skilled workers meticulously piece together various components of the eyebrow trimmers to create the final product. In the assembly workshop, skilled workers piece together various components of the eyebrow trimmers to create the final product. This involves following detailed assembly instructions and ensuring precise fitting of parts. Oil printing involves applying the company logo or branding onto the surface of the eyebrow trimmers using specialized printing techniques. Blade assembly involves attaching the sharpened blades securely onto the trimmer unit, ensuring proper alignment and functionality. Ultrasonic assembly. Bagging. Boxing packaging involves placing the finished eyebrow trimmers into boxes, providing protection during storage, transportation, and presentation to customers. Plastic sealing packaging involves enclosing the boxed eyebrow trimmers in plastic film, providing an additional layer of protection against moisture and tampering. At the heart of the production line lies the LED module assembly, where components are arranged and prepared for further processing. The LED modules undergo a series of steps to ensure their quality and functionality. Initially, the LED modules are disassembled into individual pieces before being subjected to an epoxy encapsulation process to protect the delicate electronic components from external elements. Once encapsulated, the LED modules are integrated into the lamp bodies, which serve as the structural foundation for the bulbs. This integration process involves precise placement and adherence of the LED modules onto the lamp bodies to ensure optimal thermal conductivity and heat dissipation. To further enhance thermal performance, a thermal paste is applied to the lamp bodies before the LED modules are affixed. After the LED modules are securely attached, The lamp bodies undergo a thermal test to validate their performance under varying temperature conditions. Any excess thermal paste is cleaned off during this stage to ensure optimal contact between the LED modules and lamp bodies. Following the thermal test, the lamp bodies proceed to the assembly line, where they undergo further refinement. The lamp bodies are flipped over, and any irregularities in their alignment are corrected by skilled workers. Additionally, the lamp bodies receive the necessary electrical components, such as the AC wires and bases, through automated processes to streamline production efficiency. Once the electrical components are in place, the lamp bodies undergo a final assembly process to complete the bulb structure. Automated machinery presses the bases onto the lamp bodies, ensuring a secure and tight fit. Any excess material is trimmed off to achieve a clean and uniform appearance. With the structural assembly complete, the bulbs undergo rigorous quality control checks to ensure their performance and reliability. The bulbs are illuminated for the first time, and any defective units are promptly identified and removed from the production line. Upon passing the quality control checks, the bulbs enter the aging process, where they are subjected to prolonged operation to simulate real-world usage conditions. Any bulbs exhibiting faults or malfunctions during the aging process are diverted to the repair department for further inspection and rectification. Once the aging process is complete and the bulbs pass the final inspection, they proceed to the packaging stage. Automated machinery carefully packages the bulbs into standardized containers, readying them for distribution and sale. Pressing. The process starts with the pressing of a thin strip of stainless steel into the desired shape and size of the razor blade. This step requires precision to ensure uniformity and consistency in the thickness and dimensions of each blade. Thermal process. After pressing, the blades undergo a thermal process to temper the steel, enhancing its strength and durability. This heat treatment ensures that the blades can withstand the rigors of shaving without losing their sharpness or integrity. Blade edging and polishing involve precision grinding and refining of the blade edges to achieve optimal sharpness and smoothness. Specialized machinery is used to meticulously shape and hone the edges, ensuring a clean and precise cutting surface for an effective shaving experience. Inspecting. Throughout the manufacturing process, the blades undergo rigorous inspection to detect any defects or imperfections. Coating. To enhance the longevity of the blades and protect against corrosion, they are coated with a thin layer of specialized material, such as platinum or polymer. Sintering. The coated blades are then subjected to a sintering process, where they are heated to a high temperature in a controlled environment. This process fuses the coating to the surface of the blades, ensuring optimal adhesion and durability. Sharpness test. Once the blades have been sintered, they undergo a sharpness test to assess their cutting effectiveness. This involves shaving test materials, such as hair or specialized substrates, to evaluate the sharpness and cutting performance of each blade. Soaked in anti-rust oil. After passing the sharpness test, the blades are soaked in anti-rust oil to further protect them from corrosion during storage and shipping. Quality inspection. Before packaging, the blades undergo a final quality inspection to ensure that they meet the highest standards of sharpness, durability, and safety.